Let's begin with question number 11. Okay, let's move it to a whiteboard, please, and let's read it. The equation of a curve is y equals to 8x minus x squared. Okay, to see express 8x minus x squared in the form a minus x plus b squared, stating the numerical values of a and b. Okay, let's begin with that part first, please. So this is the first part. So 8x minus x squared, they want you to write in the form a minus x plus b whole thing square. So one of the, you can do two ways. Either you complete the square, or you can just compare the identity by expanding it out like this. Okay, so we rewrite it like that. And then, ta-da! So we open the bracket and rewrite negative x squared in that order. Minus 2bx plus a minus b squared. Okay, so for comparison's sake, I'll write like this. And then this part is same as this part, the term with the x squared. So we match the coefficient of x like that. And then on the let's do this part first on the left later. That means the coefficient of x, that means 8 equals to negative 2b, from which we can solve that the value of b will be negative 4. Okay, b is negative 4. Now how about the term without the x? So we purposely add 0 like that and put these two as equal. That means a minus b squared equals to 0. So a equals to b squared, or in other words, a equals to negative 4 square, because the b is known to be negative 4 here. So a is 16. So putting back these values, we can get the form now. So that means reading off the first line again, just rewriting it nicely with these values of a and b, we see that the answer ought to be 16 minus x minus 4 whole thing square, because the b is negative 4. Okay, now let's go for the second part. Let's see what they're talking about. Hence, or otherwise, find the coordinates of the stationary point of the curve. Okay, stationary point means when the dy dx equals to 0. So dy dx equals to 0 means then we need to find the coordinates of the point. So that is one way of looking at it. So that's why they say you can use hence or otherwise. But another way of looking at it, dy dx equal to 0 occurs when it's a turning point. Turning point means where the curve turns the gradient. And that means it's either a maximum or a minimum. So in this form, they completed the square form. All we need to do is, that means we take the y equals to 16 minus x minus 4 square to find the coordinate of the stationary point. It's just like we need to put two things only. One, we put the thing inside the bracket as 0. Saying which just becomes 16 minus 0 square. That imagine this whole thing is 0. So it occurs when the x is 4. We solve this. We can see that value. And here we can see that the y, this is because the coefficient of a is negative. That means in a quadratic curve, this will be a maximum point curve like that. So the y max, that's the maximum value, is 16. So in other words, we just need to state the point. So it would be 4, 16. Okay, I will answer for this part. Okay, let's go for the next part, please. The third one. So what are they talking about? Okay, let's read and see. Find the set of values for which y is big equals to negative 20. Okay, so they require y big equals to negative 20. So let's just write that minus x squared big equals to negative 20. So the important thing in writing an inequality or rewriting an inequality like this is to bring it all to one side where the coefficient of x squared, the leading term, is positive. That means if we were to do it in this writing, bring it the other side like that, please. So x square minus 8x minus 20, 0 bigger equals 2. From which now we can deduce, let's rewrite that first. So x square minus 8x minus 20 is less or equals to 0. Okay, then we try to factorize if it can be factorized. Like in this case, it's possible x minus 10, x plus 2, less or equals to 0. Then we use the word roots just to indicate what we say, the numbers which we need to consider. Means put this 2 as 0, x is equals to, the smaller one is negative 2, or this one is 10. So just change the order. This is an important fact, especially when we draw the next part, to see the range of values accordingly. So we write like that. So this is negative 2, and this is a 10. Okay, so they say less or equals to 0. From this part, we see that. And then the can equal part means we color it like that, the dot. Let's do the same here likewise, please. So all the way like that, pull to the left. So wherever the line is, on top of that, we follow the sign less or equals 0, that means negative. In the opposite places, we do a positive like that. And then vertically, we multiply, positive times positive. Speaking about multiplying in this direction. So positive times negative is negative. Negative times negative is positive in this zone. So the overall effect of this algebraic expression is represented on these 3 green signs with respect to its sign. So we want to choose less or equals to 0 means we choose the middle. So therefore the answer will be x is less or equals to 10, but bigger equals to negative 2. Done. So that's how we do this. Okay, let's go for the 4th question, please. They say state the domain and range of g minus 1. If the function g is defined as, or defined by this part, 8x minus x squared for x bigger equals to 4. Okay, whenever they give a domain and range, please remember that we can look at it from the definition of gx. Looking at gx itself is a range, something like a y value. You can think of it like that. And the one inside it, that means the variable, this is the domain. So x value, kind of like the x value. In this case, it's also called as x. So that's how we understand this. So that means when they say they want to find the domain, so one value is kind of easy. So the domain, actually, we just copy that. That means we can just write x is bigger equals to 4. Finish. So if they use different letter than z or what, then we write z bigger equals to 4. If it was gz. Just saying an example, not in this case. How about the range of values for g negative 1x? If you notice carefully, this domain is not for this one. So a bit of a trick there. So this cannot be the answer because that is the domain for gx. See, small trick there. So you need to find g negative 1 first. So the trick is to view this. So I'm just going to write below it so we can compare easily. The thing is switched. So it's like a shortcut. So we don't need to find the gx to do it. That's why they only ask the g negative 1x. Sorry, don't need to find the g negative 1. I'm going to circle that to do it because that we can do the other after we find the other way around. That means the g negative 1x, okay, the function when you write its inverse is the range. That means the range for this is the domain for that, and the domain for that is the range. Range for that is the domain, sorry. Okay, so that means g negative 1 is still the range. Okay, and then the x is still the domain. But the x definition here and there are opposite. So when you flip means, that means what do I mean by that? Like here was x bigger equals 4 was domain here, right? So I'm going to point an arrow. So according to the switch, now this is actually the g negative 1. So in other words, the range of the g negative 1. So now I write more clearly. Range of g negative 1 is g negative 1 or just g negative 1x will be bigger, g negative 1 bigger equals to 4. So a bit of a neat trick there. Now please take note, g negative 1 is bigger equals to 4. Okay, so if we have g negative 1 bigger equals to 4, that's the range. Now how about the domain part now? Okay, let's do that part, please. So then the domain, we got to do in reverse. So the reason why I'm reading it like that is because the given function is gx without finding the, what is that? The g negative 1x we're trying to do. So if you recall just now, we could rewrite this as 16 minus x minus 4 square, right? I remember correctly. So that means now the domain for g negative 1, for g negative 1, x is talking about the x value. Okay, so the x value of that will be in reverse. Or you can see that this is actually like the y itself. It's just like the y itself. Okay, so so the y itself means, that means this is less or equals to 16. Okay, so I'm just going to write like this. Right, so x is, sorry, what am I writing? The range, sorry. The range will be, the range of, I forgot to write this word. The range of, yeah, I can write like that as well. So the domain will be x is or is it gx? Domain is x is less or equals to 16. Okay, so the domain of x less or equals 16. How do I know that? I'm thinking in reverse. The x here is the y there. That's the trick. Well, less equals 16 because this is the maximum, right? Maximum value. So the maximum value for y, less equals 16, is the x here. Please take note. Okay, sorry. Got distracted a bit. Okay, let's go back to the last part here. This thing. So find an expression in terms of x of g negative 1x. So let g negative 1x equals to 8x minus x squared. So let's try to solve that. So what we do is, sorry, what am I writing? 8 minus g negative 1x equals to y. So x equals to gy. Okay, let's substitute first, please. So this becomes 8y minus y squared. Okay, so now we need to make the y as the subject of the matter. So if we can recap, completing the square part earlier can help us to write it as 16 minus, using the x now, y minus 4 whole thing square. So y minus 4 whole thing square equals to 16 minus x. And therefore, this becomes y minus 4 equals to square root of x. 16 minus x. It's a positive root. And therefore, we can deduce now the y equals to 4 plus positive root 16 minus x. And then we just rewrite it nicely. The y is just g negative 1x. We're taking the positive root to ensure there's only a function. Can have inverse only if it is 1 to 1. So 4 plus 16 minus x. Thank you.